Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and I am recording this video on my own today. So anyway, we are going to be talking about graphing inequalities and writing inequalities, which is lesson 34 in the module 4 to be specific. But anyway, we're going to start with this bell ringer that the kids had today, and it said 6n is greater than or equal to 42. So your goal whenever you have an equation or an inequality to solve is to isolate the variable, which means get it by itself, all right? You want all of your letters on one side, all of your numbers on the other. So to do that, we're going to divide each side by 6. When you divide any number by itself, you get 1, so you would get 1n. You don't write a coefficient of 1, so you would just say n is greater than or equal to 7. Some kids were writing equals for all of these because they're so used to doing equations, and they're doing a great job with their equations. It's just you need to, if it's an equation, make it an equal sign. If it's something else, just bring that down, right? On this one, you have n divided by 8, or n over 8, is less than 56. So to undo that division by 8, you want to multiply by 8 on each side. You're going to be left with n is greater than, and when you multiply 56 times 8, you're going to get 448. All right, so any value less than 448 will make that inequality, n divided by 8 is less than 56 true. The next question here is going to be a big part of the Module 4 assessment coming up next week. So factoring and using the distributive property is a key understanding that the kids need to have. So essentially this expression, you cannot solve it as far as figuring out the value of n. There's no way to do that. We have not been given the value of n, so you can't substitute in and evaluate for it. But you can factor this. So factor meaning you can find an equivalent expression where we take the GCF, the greatest common factor of each term, and put that out in front of a separate quantity. So in this case, you're looking at 9n and 72, and you're looking for a common factor or a common number that you could multiply to get 9, that you could also use to multiply to get 72. So when you look at that, you'll see that the greatest common factor of 9n and 72 is 9, and to get 9n, you would need to multiply that by 9 by n. You're going to take whatever the operation going on in the middle is, addition or subtraction, and put that next, and then 9 times 8 is 72. All right, the next one, distribute. That means you're going to take this number on the outside and multiply it by all of the terms on the inside of those parentheses. So in this case, we have 4 times 3n, which is 12n, plus 4 times 2 is 8. And that was the end of our bell ringer for today. Our next thing that we're going to do is, I guess, go over the homework from yesterday. So exercises 1 through 8 on pages 73 and 74. It says choose a number or numbers, if any, that make the equation or inequality true from the following set of numbers. And it gives us a set of possibilities. So you're going to solve these, and you're going to subtract 5 from each side. You're going to be left with m equals 1. All right, so then what you do is you look up in this set of numbers right here and decide which numbers fit this criteria right here. So in this case, m can only equal one thing, and that is the number 1. So that would be the only number that would work out of that set, or in general. In this second example, we're going to do the same process. We're going to subtract 5 from each side. So you're going to get m is less than or equal to 1. All right, so in this case, what this means is any number that is less than or equal to 1, we can put as a possible solution. So up here, the numbers that are less than or equal to 1 are 0 and 1. Now, if we were to plug that in, plug either of those in, let's say we took 0 plus 5, that should be less than 6. 5 is less than 6. So we know that 0 checks out. If we tried, let's see, 1, you would say 1 plus 5 is less than or, oops, that should be or equal to, sorry, or equal to 6. So we know 6 is less than or equal to 6. It's definitely equal to 6. And if it meets either of the criteria of less than or equal to, in that case, it's a right answer. So we have 0 and 1 in that problem. Number 3, we have 5h, so we divide each side by the coefficient, which is going to leave you with h equals 8. And 8 is in our list of possible solutions, so we are going to say our solution set is 8. In this case, you're going to divide by each side as well. You're going to be left with h is greater than 8. So we're looking for any number that is bigger than 8. So if you scroll back up, you would say that 11 and 17 are greater than 8. And this is currently not writing. It's weird. Everything froze. Please hold. Sorry for that. Sorry about that. Something messed up with the computer. So, here we go. I have rebooted it. So you're going to divide each side by 5 with this as well. You're going to h is greater than 8. So up top you have, let's see, 8, 11, and 17 that all would meet that criteria. So 8, 11, 17 are all greater than 8. The next one confused a lot of people. When you have 1/2 y, that's the same as saying y divided by 2 equals 5. So instead of dividing by 2, we want to multiply by 2. That's going to give you y equals 10. All right, so we do not have a 10 up here in our solution set. So we need to say empty set. You do not say 0 because 0 could be a possible answer. It just is empty set or none, or just an empty set of brackets. So same thing here, you would get y is less than or equal to 5. So the numbers that are less than or equal, oh, I'm sorry, not 5. Strike that from the record, 10, sorry. Numbers that are less than 10 or equal to 10 would be 8, or 0, 1, 5, and 8. 0, 1, 5, and 8. On the next page, we have k minus 3 equals 20, so you want to add 3 to each side. You get k equals 23, and that is not one of the choices, so you would, again, say empty set. And for this one, again, add 3 to each side. You're going to get k is greater than 23. And again, we don't have any numbers in that group that are higher than 23 or even 23. So we are going to say empty set. Okay, now that we're done with that, we are going to move on to this next page. We're going to skip. If you want practice, I would recommend doing that page, and then you can always check it with your teacher. We are going to go to the next page to start writing and graphing inequalities. So the kids took some notes today about how to graph these. So if we dig right in here, it says Caleb has at least $5. So if you think of the amount of money that Caleb could have, we know that he could have $5 because he has at least 5. So you're going to put a closed circle. He could also have 6, 7, 8, and on upward. So we're going to make a line right there going to the right. And how we would indicate that is we would say Caleb has an amount greater or equal to $5. All right. In this case, we have Tarek has more than $5. So he does not have just $5. It's definitely more than that. So we want to kind of keep 5 out of this, but it's anything more. It could be $5 and 1 penny. It could be anywhere up to $1 million. We don't know, Tarek, but you use an open circle for when you just see more than or less than. When you see at least or at most or minimum or maximum, those are words that indicate that that number is included in that. So not the case with just more than. So Tarek is, his amount of money is greater than 5. Vanessa has at most $5. So here's $5. That's the biggest amount of money she has. It could be anything less than that. That $5 is kind of where it's capped off. So Vanessa's amount is less than or equal to 5. Right, so again, if you see this line, I will underline it in blue. If you see this line here, that means you need to fill in the circle to indicate it's included. Okay? So I think a lot of confusion comes from, like when you say at least, you think less than is least, but that means that's the absolute lowest amount he has, so he has more than that amount. Plus, you know, he could also have that amount as well. Li Chen has less than $5. So again, less than is an open circle, and that would be going to the left. You'll notice that these arrows that I am highlighting in red, they go in the same direction as these inequalities on the number line. Okay? Less than goes to the left. Numbers that get bigger, greater, go to the right. All right, so the notes that I had the kids take today, that should be in their module, include this. So if you see at least, that means it's that amount or greater. So greater than or equal to, you indicate that with a closed circle, and because we're looking for numbers bigger than that amount, it's going to go to the right. Another word for at least you may see is minimum. Alright, so again, that would go to the right on a number line. Right, the opposite of that would be at most. That means all the numbers would have to be less than that amount or equal to that amount, and that would be indicated by a filled in circle going to the left with the arrow, and maximum would be our synonym for the phrase at most. Somebody today said that their parents will tell them, at most I'm giving you $5. Okay, so that means they'll give them less than that, but they're not giving them any more. You know, the highest amount that they would get was, I think, like $10. Okay, so, oh, one more thing. Less than is going to be an open circle, and again, the arrow points in that direction. Greater than, we're looking for numbers that go to the right and are bigger. So that's kind of your key when you're doing this. When we go down here to example 2, we have some more wording, and it makes it a little trickier. It says, Kelly works for a quick oil change. If customers have to wait longer than 20 minutes, so longer than 20 minutes, the company does not charge for the service. So if you wait 1 minute, 2 minutes, 3 minutes, all the way up through 20 minutes, you are going to pay for it. But if you wait more than 20 minutes, you're not going to have to pay. It says the fastest oil change that Kelly has ever done took 6 minutes. Show the possible customer wait times in which the company charges the customer. So it's really important that you read these questions multiple times and pay attention to what they're asking you to graph. So they're asking in this case to indicate where you would be charged. So you're definitely getting charged if you wait 20 minutes and if you do anything less than 20 minutes. So that's how you would write that on a number line, and you would say, let's say your wait has to be less than or equal to 20 minutes for the times in which you are going to be charged. Okay, down here in example 3, it says Gurnaz has been mowing lawns to save money for a concert. Gurnaz will need to work for at least 6 hours to save enough money, but he must work fewer than 16. When you see fewer than or more than, think of less than, greater than, sorry. Write an inequality to represent the situation and then graph the solution. So at least 6 hours. So that means it includes 6 hours. He has to do 6 or more. but he cannot work, or he must work fewer than 16. So he can't quite work the 16th hour there. He can work 15 hours and 59 minutes and 59 seconds, but he can't get to 16 hours. So he's got to work more than 6, but less than 16. So what you do here is graph that area in between, and you would, let's say, H for hours, okay? And you're going to list the numbers right here and here in order from least to greatest, like this, all right? And we see that it's at least. So in terms of the hours, okay, the H, he needs to work an amount greater than or equal to 6. And we know that his hours have to be less than 16. So reading this inequality, you would say 6 is less than or equal to H, which is less than 16. Okay? Again, when you're writing inequalities, these inequality arrows, the symbols for less than and greater than, need to be going in the same direction. Okay? And you read them left to right. That's all we were able to cover in class today, but I will go through some more examples so that anyone watching this at home who needs extra help can see some more. So on the next page, it says, write an inequality to represent each situation, then graph the solution. Blayton is at most 2 meters above sea level. So 2 meters would be right here, but we want at most. So that's the highest he is as far as sea level, and we are going to put a closed circle. Pretty much what you have to do is figure out what number you're talking about, and are we including it or not including it, and then are we talking about the numbers greater than that or less than that to determine which side we put the arrow on. So in this case, we're talking about 2 meters above sea level, and that's at most. It means it's the highest elevation that he is. All right, so he could be at any of these lower ones. So you would say Blayton is less than or equal to 2. Number 2, it says